All right, Dave, take it away.
All right, great. Hello, everyone. So, real quick, we're going to we touched on this in a previous video about ransomware and how simple ransomware is. So, with that, I kind of wanted to go through some example code on a GitHub post and then a another GitHub post that talks about ransomware as a service. And then before we do that, we'll look at a little bit more talking about source code and then how that aligns to a particular APT known as Wizard Spider and how you can kind of get to understand a little bit more of that. All right, so before we begin, right, there are many different types of encryption out there, but really there's two types of encryption that we really are concerned about. So there is symmetric encryption and there's asymmetric encryption. So there is some math and other things that are involved in that, but what we really need to understand is how we have this idea of a key, right? And so there is a secret key, right, that is used in symmetric encryption, right, as this discusses, to kind of encrypt and decrypt communications, right? And then once the data is converted into that form, it can only be used by somebody with the secret key, right? So we can click on this example and hopefully this will come through. Great. So this little picture example here, right? So there is, if this image will come up, we can talk a little more about it. But the whole idea here is there is a single key, and that single key is used to encrypt and decrypt a document, right? Or any file, any data stream, right? So the data goes in as plain text, and then it hits an encryption algorithm, right? And that algorithm is some mathematical implementation of shifting the information around. And the way that the information gets shifted around is based on this key. And this key basically informs to the algorithm, hey, this is how complex I want you to shift it around. And this is also like the known way to bring it to encryption and bring it out of encryption. So once it's encrypted, we call it ciphertext. And then we decrypt it, and then it comes back to plain text, right? And then there's also this idea of asymmetric encryption, where and this can kind of be illustrated a little more like this, where there are there's two keys in asymmetric encryption as opposed to symmetric encryption, right? So with that, we'll click on this little image here, and hopefully that's large enough for everybody to see. But basically this, right? So you take a public key, right? And that public key is known to everybody, and that's also how you prove your identity. And then that's what's used to encrypt the data. And then once the data is encrypted, it can only be decrypted by somebody's private key, right? And there's something called a key exchange, known as the Diffie-Hellman key exchange. But so that's just some general groundwork. We're going to be focusing mainly on asymmetric encryption when we're talking about ransomware. Anyhow, so let's take a look at it, right? So there is this GitHub link by this developer, n00bz, and n00bz has a Python ransomware here, right? And this is there's a tutorial where you can read and look at it, and there are some things that you would need to edit if you actually wanted to test this on your local machine, right? And again, the disclaimer, as always, like what we're talking about here is for testing and academic purposes, and strict consent is necessary, right? Like, so you can't just go out and fire this off on any system. It's best if you just only test this on your local system, say in a VM. So with that, let's take a look at the actual ransomware file itself, right? So this is the ransomware code, right? It's only 257 lines of code. And it starts out by importing a bunch of different libraries here, right? So first off, we need to talk about like what are libraries in Python. this is just a way to extend your code. You can think of this as like when we're writing code, we don't always start out with everything that we need. We could go and write each individual component that will do these different things for us, right? Like talk to the OS, load a web browser, right? Interact with C types, like which is how to interact with Windows DLLs, date and time, encryption, so on. But if a language is mature enough, it'll have library systems. And so we can import those into our code, and then we can start interacting with those objects or functions. In this case, you would then be interacting with these functions, right? So a lot of these calls are brought in, and it sets it all up. And then it defines a class, right? So they're saying this is what the ransomware will go out and encrypt, right? And so they're saying that they have a flag in here that's like only chooses the files that we want to encrypt and leaves other files unencrypted, et cetera, PNG. So in this example, if you loaded this code, it would only encrypt extensions that end in TXT, right? Which these different libraries would interact with, right? So OS, for instance, would interact with that, and this cryptography for net. So this would start setting up another def, and this idea here is that it sets up a fernet object that will then do the encryption and decryption using RSA public key cryptography. So it sets up a public key, but the way that they're implementing it is through symmetric key encryption, right? So there's a single key that's going to be generated that is used to keep everything set up. So in their example here, right, if we looked back at their code, they said that you needed to set up a local path, and this local path is actually where you are going to store the keys that are going to be generated out of this stuff, right? Do not use self-root on your PC. Let's skip your own system. Create a mini root directory to see how the software works, and then set some folders in there, right? So they're saying that they've set their local path here to this specific directory. If this was like other ransomware, right, that may not be written in something like Python, but is a compiled language, you would have a similar variable that would define the root of the system, or be smart enough to go out and understand what is the entire root of the file system. In this case, d:// like this denotes a drive in Windows, and then these are directory paths. And so going this far deep into a path ends up in local root. And then they're getting a public key, right? So a public IP, right? Sorry, not key. And they're doing it for more analysis, right? Saying if you hit gov military IP space LOL, basically the idea being is that most ransomware would be then forwarding out the encryption key that's created out to some remote server, right? In that case, that may be using asymmetric encryption, right? So there's a public key that gets brought over to the system, and then there's a private key that is generated by the ransomware, and then that would be put out on an IP. In this case, they're keeping it simple and using symmetric encryption, and the key would be deposited locally on the system, right? So they write out the symmetric key to a file, right? So that file is there so that you can go back and decrypt the files. And now after they've generated the key, they use that same key, that fernet key, right, that TXT, to then encrypt the files, right? And then this will go through and this will encrypt those specific ones, right? And then they're also having something that opens an email and writes to a TXT file that'll write out the encrypted key to the desktop so that it can be sent back as well. And it goes on, it keeps encrypting. So it's going to go full, encrypt all files in that directory that end in that extension that we were looking at in the beginning of the code, right? And so it's going to write those out. It's going to log those for debugging. As this was executing, these different print statements that you would see would be being executed at a Python interpreter. right? So some CLI output that you would see, or in a Python ID. And then crypt system, right? So encrypts and decrypts files in the system using the symmetric key that was generated on the victim's path, right? So pulling in this information that came from these previous functions, it would then encrypt them, and it's saying encrypted is set to false, whereas up here it's being set to false. So again, it would just keep setting it up, right? And so this example code would then do another call, which would open a web browser and then bring you to bitcoin.org, right? And then the general idea here is that when ransomware is executed on a victim system, normally it'll deposit some kind of Bitcoin address, right, that you need to send money to, right? And then they will send back the symmetric key or the asymmetric private key so that you can decrypt your files, right? So this is kind of what this static call is talking about here. Another one, this is also pretty typical that you might see for ransomware if you ever have to do incident response, is that the background of a computer will change, right? Or in other cases, it will actually lock the computer itself, so it's set only to the specific image. In this case, it's bringing you to this large JPEG, right? So if we browse to that, we could actually see what they're talking about here. So this would then be displayed on the victim's, on your example machine desktop background. Right, so we'll close that. And another thing that this Python code will do is it creates a TXT file, right? So this TXT file writes out saying, your hard disk has been encrypted with military grade encryption. That's what they're calling the RSA AES encryption that they're using here. And then email file called email txt to get your files back, protonmail.com. You'll receive a personal Bitcoin address for the payment. Once the payment has been complete, send another email saying paid, and then we'll see if it's paid. You'll receive your key that will unlock all your files. Place the place the key on your desktop and wait. Shortly, it will begin to decrypt all files. Do not attempt to decrypt the files yourself. Blah, 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 blah. Disobedience. Do not send paid button without paying. And so this actually opens this ransomware note that's being created in a notepad that's being called through the subprocess, right? If we saw up at the top of the code, that was a library that is imported subprocess that opens notepad.txt and displays ransomnote.txt, right? And it does sleep and it puts it on top, right? Ransom note is on top, do nothing, so this gets spit out at the CLI. Create process again, kills the ransom note so we can open again to make sure the ransom note is in the foreground, blah, blah, blah. And so this is here where they're talking about, right? So this key, once you get the decrypt key, you put it on the desktop, and then this is a constant loop that's running as this Python code is executed. And it's waiting to see if the key gets picked up, right? And so once the key gets picked up, it will decrypt the files that were put in that, this decoding Python ransomware software test file PNG, right? Obviously, you would need to change these if you were actually experimenting with this on your own, but that's kind of this idea, right? So once it picks up that the key has come out, then it will go through and it will decrypt that code by calling some of these functions that are back up in here that will decrypt the files, the TXT files that are in that absolute file path that you've set within the code. And then it will, once this is done, it'll exit out. And then this is the main from where all those different calls come from, where it's going to execute each of those different functions, right? And then here's some at the bottom, right? So attack completed on machine is encrypted, waiting for attacker to give the target machine document that will unencrypt the machine. And so once this loop is executed, it'll say ransomware is complete. a machine has been unencrypted, right? So that's all well and good. But what does this basically mean when it comes to what we're talking about for ransomware? Well, so here's another URL, right? That just wanted to like look at some of the ransomware that are freely available on the internet, right? So imagine a scenario: you get an email, right? And then you click on this link, and then in a few minutes your system gets slow, unresponsive, right? So what's kind of happening here is that when you clicked on that, some PowerShell or some macros were activated that brought down, as they're saying, this Ares locker ransomware that is actually Python, right? And so this does the same kind of thing, right? So it puts a banner out that says, please enter your password, and sets at the login screen a fake login that will get your password. And then so no matter whatever, it will not matter if you enter a password because this function will run anyway. So this is just like to kind of trick the user. It'll scan here, and then it will look for all these file types, right? So if we look back here, and we have file types, right? And then it's going to import some queues and threads, and then it's going to go in and it's going to call the class and use AES encryption to actually lock the files that are being brought in, right? And so the last part of the execution, it'll create a README TXT, right, that says, hey, you've been hit by this ransomware, and it'll open a pop-up that says check the README, which is kind of this background, same kind of idea that we saw here in this example code, where this key, this TXT file gets popped up, and the background will change to say ransomware. Same kind of idea that's occurring here with this Ares ransom. And this article goes further to talk about it, but why do I want to talk about that? Well, okay, so kind of get the idea here, right? Like, so there is some kind of vector path that brings something very similar of this very simple Python code that activates on the system, right? And so how does that relate, right? Well, okay, so doing a bit more digging, I found another Python project called RAAS net. And so this is an example of ransomware as a service, right? And so I don't have this running right now. There's a demo that you can go take a look at. But essentially the idea being is you would run this on your local machine, and then you can generate a payload for a specific computer type, and then you would get a dashboard that collects the metrics of when your ransomware checks back in, right? And then you can set what type of encryption type, and then what it will do, right? So like self-destruct or run as admin, and then set the specific target directory, custom file extensions, and whatever, and then you hit generate. And this is just a graphical front end, right, for you to think about that, again, this is Python code that's being run. So you would run this locally on your system, and it would do some Python calls that would display this nice little web server. And it's saying that it works on all these different platforms, and they want you to recompile it. This is do not earn money or break customers. This is just for a presentation. So again, this is just for demonstration and understanding, right? So importing similar kind of libraries, right? AES and other things like that, and a bunch of other libraries to produce that graphical user interface that we were seeing. But it's just Python, right? It's a simple language that can be easily picked up reading articles online. And the general idea here is you get this dashboard. It'll be able to call out through an IP of where it's being hit. You could run this on some kind of cloud server, so you have all the callbacks coming to you. Seems like you're hit by demo ransomware, right? So you go to this key and IP and get it all back, right? And then so here's an example of the actual ransomware running. It's encrypting these pictures. Pictures apparently are very important to people, and people want them back. And the idea being is that once the demonware has encrypted everything, then you would be able to decrypt them once they give you the code back, right? In their case, they're saying that they have a Python code that's used, right? And there's a demo link that we could click. But the idea here is that with or without a GUI, you can generate your payload. You get kind of a dashboard where you can see where everything's working. You can set up verified access through a VPN in order to gain access to it, and so on. And so why am I showing you that? Okay, so a lot of the ransomware that you're hearing about on the news, right, like that Colonial pipeline that got hacked and other industries that got hacked, were hacked with ransomware that was coming off of ransomware as a service. So somebody would go out on the darknet, the same kind of idea here, right, to one of these command and control domains that they would get through something else, through like a forum. They'd pay a fee and they'd be given a username and password, and then they can run their campaign. And then the developer of this, right, like how they're saying, buy me a coffee, in the case of some of these ransomware as a service, they would actually get that as a small percentage, right? And all they're really doing is they're just selling a platform that's like, all right, yeah, once you've gotten access to a system, you can use our ransomware as a service to generate your payloads, run your campaigns, get everything back. Like they even, and some of those portals actually have like e-commerce and other functionality like that, right? Where like you could buy additional add-ons to it. So why am I showing that? All right, well, so here is MITRE ATT&CK, the MITRE ATT&CK frame. And we're looking specifically at a group called Wizard Spider. And what Wizard Spider has is they have these different techniques, right, to gain access to a system, right? So they use domain admins, they use HTTP for calls, they're able to drop these keys. They use VPN infrastructure to like mask their how they're doing things. But if we look a little closer here, right, so they start installing something called TrickBot. And TrickBot is another type of malware, right, that's developed by other groups that WizardBot has brought into their attack methodology. And so even right here, right, so like this link that we talked about, the source code here, Wizard Spider will use spear phishing and attachments to deliver Microsoft documents containing malicious links to download either Emotenet or TrickBot. All right, so if we look a little closer at what TrickBot can do, it's a piece of software, right, that's a Trojan spyware program that was initially designed to target banks, but it's been extended a lot in order to have it do a whole lot of other things, right? So it's entirely modular, kind of like a Swiss Army knife. You can plug and play different pieces of malware into TrickBot so that it can do what it needs to do. And in this case, TrickBot could be used to bring in a second piece of software, right? In our case, it could be a type of ransomware, right? So this was just my little take on this. I had hoped that I would have a VM up and running. Perhaps I can do that next time, where we can actually take a look at generating some of our own ransomware and then dropping it on a Windows machine just to see how it works, right? But I wanted to give kind of a talk about this because we hear about ransomware a lot on the news, and it is a threat. It is a problem because it's disrupting a lot of industries. But ransomware is actually very simple for people to implement. These same sort of functions, you could implement these in Java, you could implement these in C++, you could implement them in C, you could implement them in Go. And a lot of people actually go out and handwrite programs like this because they haven't been picked up by AV systems. right? In this case, this one probably would, but that's that general idea, right? Like if you don't reuse code that somebody's already written, an AV system may not be able to detect it. It may only be able to detect it based on the behavior of what it does. But the whole process of ransomware getting onto somebody's target system is actually a very varied issue, right? Like, so Wizard Spider might only be might actually gain access to these targets from another attack group. They may have their they may be paid, right, to go out and drop ransomware on somebody's system, but that doesn't necessarily mean that they're the ones who are running the entire ransomware campaign, right? That may be done by somebody else. So that was just kind of my general overview, very briefly about ransomware, and kind of an example dive into a ransomware example Python code. So with that, are there any questions or comments? I think I'm done.
Very good. I thought that was very informative. And as you brought up the point, uh, ransomware has been making the news. It's sort of a very hot topic, but unfortunately, for a lot of the non-technical people, they don't sort of really understand how it works under the hood. And basically the fact here, and this sort of really touches on the point I made earlier about technology being dual use. So basically, under the hood, it's just using RSA, which is like a 40-year-old technology to encrypt files. But in this case, it's encrypting it for nefarious purposes, right? To force the
Right.
users of those files to cough off money. But if you wanted to send me a file that only I could read, you would use the same technologies so other people can't snoop on your file. So that's sort of a legitimate purpose. And so, yeah, I think this is sort of very eye-opening and will help people to sort of understand, hey, this is what ransomware is, and sort of be able to better understand the proper context of it, and sort of understand how these different threat actors are actually using it. And that's this isn't magic, and it's not like, oh, you look the wrong way and you're going to get ransomware. No, there are very specific steps an adversary has to go to then to finally launch the Python or however the implementation is. But yeah, good stuff.